3,331, 12 cubed is 1,728, 13 cubed is 2,197, 14 cubed is 2,744, 15 cubed is 3,375. And now without their hooks. 1,331, 1,728, 2,197, 2,744, 3,375. And reverse. 3,375, 2,744, 2,197, 1,728, 1,331. And by digits. 1331, 1728, 2197, 2744, 3375. And reverse. 3375, 2744, 2197, 1728, 1331. Faster. 3375, 2744, 2197, 1728, 1331. And the next cluster. Now, we believe 16 cubed is 4,096, 17 cubed is 4,913, 18 cubed is 5,832, 19 cubed is 6,859, 20 cubed is 8,000. So we must check, as these are of high importance. 17 cubed is correct, 18 cubed is correct, 19 cubed is correct. Alright. 16 cubed is 16 cubed is 4,096, 17 cubed is 4,913, 18 cubed is 5,832, 19 cubed is 6,859, 20 cubed is 8,000. And without their hooks. 4,096, 4,913, 5,832, 6,859, 8,000. And again. 4,096, 4,913, 5,832, 6,859, 8,000. And reverse. 20 cubed is 8,000, 19 cubed is 6,859, 18 cubed is 5,832, 17 cubed is 4,913, 16 cubed is 4,096. Without their hooks, 8,000, again, 8,000, 6,859, 5,832, 4,913, 4,096. And by digits, 8,000, 6,859, well rather forward by digits first. 4,096, 4,913, 5,832, 6,859, 8,000, and again. 4,096, 4,913, 5,832, 6,859, 8,000. And again, 4,096, 4,913, 5,832, 6,859, 8,000. And reverse. 8,000, 6,859, 5,832, 4,913, 4,096. And again, 8,000, 6,859, 5,832, 4,913, 4,096. And again, 8,000, 6,859, 5,832, 4,913, 4,096. Great. Okay. Now we begin with arithmetic. Okay. Actually, that's set A. We just need to go to set B. Which is here. Okay. Part B, set 2. Hello. Write 0.1 recurring 6 as a fraction in lowest terms. 0.1 recurring 6. Okay. So that's 2 over 30 plus 1 over 10. 2 over 30 plus 1 over 10. Which is 3 over 30 plus, rather 2 over 30 plus 3 over 30. Which is 5 over 30, which is 1 over 6. 1 over 6. 0.3 recurring 1/8. 0.3 recurring 1/8 as a fraction in its lowest terms. So that's 3 over 10 plus 18 over 990. 3 over 10 plus 18 over 990. Times the top and bottom by 99. So 297 plus 18 over 990. So 315 over 990. So 35 over 110. So 7 over 22. (0.58) recurring 3. 0.58 recurring 3 as a fraction. 58 over 100 plus 3 over, rather 58 over 100 plus 1 over 300. So 174 plus 1 over 300. So 175 over 300. (0.4 recurring 5 as a fraction in its lowest terms. So 4 over 10 plus 5 over 90. 36 over 90 plus 5 over 90 is 41 over 90. (2.4 recurring 3/6). 2.4 recurring 3/6. So 0.0 recurring 3/6. We know 0. Recurring 3/6. It's 36 over 99. Which becomes 12 over 33, which becomes 4 over 11. And then 4 over 110. 4 over 110. Or rather 2 over 55. So 2 over 55 plus 24 over 10. times the top and the bottom by 5.5. 132 over 55 plus 2 over 55, so 134 over 55. Five over 7 as a repeating decimal. 0.714285. Recurring. Recurring 285 147 is k over 7 for an integer k. Find k. The answer is 2. Three over 70 is a decimal with a repeating block. 0.0 recurring 428571. Ten over 7 is a decimal. 1 point recurring 428571. One over 7 plus 1 over 70 is a decimal. So that's 11 over 70. Eleven over 7 so it's 11 over 70. Now we know that 11 over 7 is 1 point recurring 571428. So this will be 0.1 recurring 571428. And now we move on to chapter 2. 6x squared take x take 12 equals 0. Three x at 4 times 2x take 9. No, 3x at 4 times 2x take 3. So minus 4/3 or 3/2. So solve 2x squared minus x minus 12 equals 0. And we say minus 4/3 or 3/2. No, wrong. We say solve 6x squared minus x minus 12 equals 0. And we say minus 4/3 or 3/2. X to the 4 take 10x squared add 9 equals 0. So we say x squared minus 1 times x squared minus 9 equals 0. So x add 1 times x take 1 times x add 3 times x take 3 equals 0. So x is plus or minus 3 and plus or minus 1. So you say solve x to the 4, take 10x squared at 9x equals 0. And we say x is plus or minus 1 or x is plus or minus 3. Solve x, take 5 root x plus 6 equals 0. We believe it's root x take 3 times root x take 2 equals 0. So x is root 2 or root 3 in the positive. Solve x squared minus 5 root x. No, rather you say solve x minus 5 root x plus 6 equals 0. And we say x is root 2 or root 3. So 6 over x equals x, take 5. 6 over x equals x, take 5. So 6 equals x squared, take 5x. So x squared, take 5x, take 6 equals 0. So x takes 6 times x add 1 equals 0. So x is 6 or negative 1. So you say solve 6 over x equals x, take 5. and we say x is negative 1 or 6. Given that x squared at bx at c equals 0 has the roots negative 7 and 2, find b plus c. Find b plus c. So we multiply x at 7 by x take 2. And we get x squared at 5x take 14. So the sum is negative 9. So you say x squared at bx at c equals 0 has the roots negative 7 and 2. And you ask us what is b at c, and we say negative 9. Okay, section 2 is completing the square, CTS. Write 3x squared, take 12x at 7 in the form a times x at b all squared add c. We'll pull out 3 from the first two terms. Then we get 3 times all of x take 2 squared. Now when you square that out, you generated 12, so you have to take away 5. So 3 times x take 2 all squared, take 5. So you say, write 3x squared take 12x at 7 in the form a times all of x at b squared plus c, and we say 3 times all of x at 2 squared, take 5. Find the minimum of 2x squared at 6x at 1. We need the minimum. We use the line of symmetry, minus b over 2a. So minus 6 over 4, which is minus 3 over 2. And we substitute. So we get 9 over 4 times 2, which is 9 over 2. Then 9 over 2 minus 18 over 2. So 9 over 2 minus 9, which is minus 13 and a half. Minus 13 and a half plus 1 is minus 12 and a half. So you say, find the minimum of 2x squared at 6x at 1. And we say minus 13 and a half. Minus 12 and a half, minus 12 and a half. Hello? Write 5, take x, 5 minus 8x minus x squared in the form b minus the square of x at a Did you say 5 minus 8x minus x squared? Oh, you did. Okay. Now, if we square x at 4, we get x squared at 8x at 16. But we want to take that away. So we will end up taking away a 16. But we have 5. So we need to add 21 to correct it. So the answer is 21 minus all of x at 4 squared. So you say, write 5 minus 8x minus x squared in the form b minus all of x at a squared, and we say 21 minus all of x at 4 squared. Solve x squared minus 6x plus 2 equals 0 by completing the square and giving exact answers. So we have x minus 3 all squared. That gives us the first two terms, but it gives us a 9 and we have a 2, and therefore we have to take away a 7. That minus 7 moves over to the other side, and then we square root it, so we have plus or minus root 7. And then it will be 3 plus or minus root, no, yes, it will be 3 plus or minus root 7. So you say solve x squared minus 6x plus 2 equals 0. And we say 3 plus or minus root 7. Given x squared at px at 20 is equal to x at 5 all squared at q, find the sum of p and q. X at 5 all squared is x squared at 10x at 25. So p is 10. And then on the right hand side we have 25 at q. And on the left hand side we have a solitary p. Or rather a solitary 20. So 20 is 25 at q, so q is negative 5. Now we put together negative 5 and 10 and we get 5. So you say x squared at px at 20 is equal to x at 5 all squared at q. And you ask us to find p plus q, and we say 5. Section 3 is the quadratic formula. Solve 3x squared, take 5x, take 1 equals 0, giving exact answers. Discriminant first. 25 at 12. 37. 5 plus or minus root 37 over 6. So 3x squared minus 5x minus 1 equals 0, giving exact answers. Root 37. So 5 plus or minus root 37 over 6. That's what we say. Two x squared add 4x, take 3 equals 0. So we have 40 root 40. 2 root 10. Minus 4 plus or minus 2 root 10. All over 4. Minus 1 plus or minus root 10 over 2. So you say solve 2x squared add 4x, take 3 equals 0, giving your answers as so it's in simplest form. We say minus 1 plus or minus root 10 over 2. X squared minus 2x minus 4 is equal to 0. Two plus or minus 2 root 5 over 2. So we say 1 plus or minus root 5. So you say solve x squared minus 2x minus 4 equals 0. And we say 1 plus or minus root 5. Hello. Five x squared minus 2x minus 2 is equal to 0. Try again. Solve 5x squared minus 2x minus 2 is equal to 0. Two plus or minus 2 root 11 over 5. No, 2 plus or minus 2 root 11 over 10. So 1 plus or minus root 11 over 5. 1 plus or minus root 11 over 5. So you say solve 5x squared minus 2x minus 2 is equal to 0, and we say 1 plus or minus root 11 over 5. The roots of x squared minus 6x plus 4 is equal to 0 are a plus or minus root b. Find a plus b. So 6 plus or minus 2 root 5 over 2. So 3 plus or minus root 5. So we say the answer is 8. So you say x squared minus 6x plus 4 is equal to 0, has roots in the form a plus or minus root b. And they say find a plus b, and we say 8. The discriminant and the nature of roots. Find the range of values of k for which x squared at kx add 4 equals 0 has no real roots. Right? Yeah. Find the range of values of k for which x squared at kx add 4 equals 0 has no real roots. So we need b squared minus 4ac to be less than 0. So in this case that would be k squared minus we're dropping it. Again, find the range of values of k for which x squared at kx at 4 equals 0 has no real roots. So we use b squared minus 4ac, needing it to be less than 0. So k squared minus 4 times 4 times minus 4 times 1 times 4 has to be less than 0. So k squared minus 16 has to be less than 0. So k squared has to be less than 16. And so k is any value strictly between negative 4 and 4. So you say find the range of values of k for which x squared at kx at 4 equals 0 has no real roots, and we say that k is strictly between negative 4 and 4. Find the range of values of k for which kx squared at 6x at k equals 0 has equal roots. In this case, we need b squared minus 4ac to equal 0. So 36 minus 4k squared would have to equal 0. So 36 equals 4k squared, so 9 is equal to k squared, so k is either plus or minus 3. So you say find the range of values of k for which kx squared at 6x at k is equal to 0 has equal roots, and we say k is plus or minus 6. Is that right? No. You say find the range of values of k for which k squared at 6x at k is equal to 0 has equal roots, and we say that k is plus or minus 3. Find the range of values for which 2x squared at kx at 8 equals 0 has distinct real roots. Hello. Find the range of values of k for which 2x squared at kx at 8 equals 0 has two distinct real roots. So in this case we need b squared minus 4ac to be greater than 0. So k squared minus 4 times 2 times 8 would have to be greater than 0. So k squared minus 64 would have to be greater than 0, so k squared would have to be greater than 64, so k would have to be greater than 8 or less than negative 8. So you say find the range of values of k for which 2x squared at kx at 8 equals 0 has two distinct real roots, and we say that k has to be greater than 8 or less than negative 8. State the number of real roots of 3x squared take 4x at 2 equals 0. Rather, state the number of real roots of 3x squared take 4x at 2 is equal to 0. 3x squared take 4x at 2 is equal to 0. We apply the discriminant to b squared minus 4ac. So the square of negative 4 minus 4 times 3 times 2. So 16 minus 24. 16 minus 24 is negative 8, so it has no real roots. So you say, state the number of real roots of 3x squared minus 4x plus 2 equals 0. And we say it has no real roots. Find the range of values of k for which x squared plus k at 3 all times x plus 4k equals 0 has equal roots. So I have to square k at 3 and take away 4 times 1 times 4k, and that has to equal 0. So I have to take away 16k. I have to take away 16k. But to do so, I have to square k at 3 first, so k squared at 6. K squared at 6k at 9. K squared at 6k at 9. So k squared take 10k at 9. So k take 9 times k take 1. So k would have to be 1 or 9. 1 or 9. So you say find the range of values of k for which x squared add k at 3 all times x add 4k equals 0 has rather equal roots, and we say 1 or 9. You say 1 or 9. Okay, so sketching now. State the coordinates of the turning point of y equals x squared minus 8x plus 21. To get the coordinates of the turning point, you can just complete the square. So y is equal to x take 4 all squared plus 5. And if that's the case, then it would be 4, 5. So you say find the coordinates of the turning point of y equals x squared. Take 8x. Hello. So you say find the coordinates of the turning point of y equals x squared minus 8x plus 21 is equal to rather, find the coordinates of the turning point of y equals x squared minus 8x plus 21. We complete the square. So y is equal to x take 4 all squared plus 5. Then the coordinates are 4, 5. Okay. What is the minimum number of 5 by 30 rectangles needed to tile a rectangle with sides in the ratio of 4 to 5? We reduce 5 by 30 to 1 by 6. Then it's either 4 times 30, which is 120, or it's 5 times 12, which is 60. And we believe the answer is 60 then. So you say, what is the minimum number of 5 by 30 rectangles needed to tile a rectangle with sides in the ratio of 4 to 5? And we say it's 60. We say it's 60. And what you need to do We're going to say that 4 to 5 is the height by the width. 4 to 5 is the height by the width. And we're going to stack the rectangles so that they're 30 by 5, as in 30 is the height and 5 is the width. That's how we're going to do it. Okay. PQRS are 4 points lying on a line in that order. PR is 6 centimeters. QS is 4 centimeters. And R is 1 centimeter closer to S than it is to Q. So find the length from P to S. We're going to say QR is 2.5 and RS is 1.5. And because of this, PQ must be 3.5. So 3.5 at 2.5 at 1.5. That makes 7.5. So you say 4 points lie on a line called PQRS. You say PR is 6 centimeters and QS is 4 centimeters and point R is 1 centimeter closer to S than it is to Q. And then you ask me for the distance between P and S. And I say 7.5 centimeters. Find the difference between the largest and smallest 2-digit primes that have only prime digits. It will not be 97. It will be something in the 70s. 79 is a good guess, but then we see that that can't be right. is 73. 73 is the largest prime with prime digits. And the smallest two-digit prime with prime digits is not 11. In fact, it's nothing in the tens at all. You would be in the 20s if anything. So we say 23. So it would be 73 take 23, which is 50. So you say find the difference between the largest and the smallest two-digit primes with prime digits, and we say the answer is 50. Three consecutive one-digit positive integers are a square, a cube, and a prime. Find their product. We believe it's 7, 8, and 9 because 7 is a prime, 8 is a cube, and 9 is a square, of course. And their product is 504. So you say three consecutive one-digit positive integers are a square, a cube, and a prime, and ask us to find their product, and we say 504. Find the difference between the largest two-digit multiple of 2 and the smallest three-digit multiple of 3. The largest two-digit multiple of 2 is 98. The smallest three-digit multiple of 3 is 102. And their difference is 4. You say find the difference between the largest two-digit multiple of 2 and the smallest three-digit multiple of 3, and we say 4. A train scheduled 1748 to 1825, that is 5:48 p.m. to 6:25 p.m. is 4 minutes late and takes twice as long. How long is the train journey altogether? No. A train scheduled from 5:48 p.m. to 6:25 p.m. arrives 4 minutes late and takes twice as long. When does it arrive? So it should take 37 minutes. But instead, it's now going to take 74 minutes. And if it arrived on time, that would be 1 hour and 14 minutes. Which would bring us to 2 minutes past 7, but it was late by 4 minutes, so it's going to be 6 minutes past 7. So 1906. You say the train was scheduled 17:48 to 18:25, but it arrived 4 minutes late and it took twice as long. And you ask us when it arrived, and we say 19:06 or 7:06. Jasmine finished a race in 59 hours, 58 minutes and 21 seconds, beating a 60-hour cutoff mark. By how many seconds did she beat it though? We say she beat it by 99 seconds. So Jasmine finished a race in 59 hours, 58 minutes and 21 seconds, beating a 60-hour cutoff mark, which means that she beat it in 99 seconds. She had that many seconds to spare.